So hi Ojas. So I'll be starting the session in like 2-3 minutes so that a few others can also join the session. So I guess I'll start discussing problem statements like in 3-4 minutes. Let's say around 6-5 or let's say 6-7. So I'll start in for 5 minutes. Okay, so I guess since 2-3 of you have joined, so we can start the session. So first of all, hello everyone. Uh, Welcome to the course, and this is the first session of the NPTEL Discrete Maths problem solving sessions. So my name is Lakshya Saggi, and I'll be a problem solving TA for the. Uh, this week I'm taking the session from Tuesday 6 to 8 p.m. But from next week onwards, I'll take the sessions on Mondays from 6 to 8 p.m. So same timing but different day. So yeah. So there will be overall, as you may know, that there will be 12 such problem solving sessions since the course spans 12 weeks. So based on every week's content, we'll be having one problem solving session, which will help you guys to solve the quiz problems for that week. So yeah. So in the first week, I guess uh, the most of the discussion in the lectures was around permutations and combinations. So I've prepared a set of problems based on permutations and combinations only, and we'll be discussing those problems because they'll help you. As I already said that they'll help you solve the quiz problems also. So I guess we can get started. I'll just share my screen and Yeah, I can just start discussing. Okay, so another thing to note is that uh, since I can't hear any of you, like I have disabled voice for everyone. So if you feel that you have any doubts at any point of time, feel free to stop me and ask me in chat. So I'll be actively looking at the chat if there are any questions or any doubts, and if there are, I'll try to answer them to the best of my capabilities. And also, if you face any technical issues like my voice is not audible or maybe my screen is not visible when I'll start sharing the screen, you can inform me via chat that also. So that I can fix it for you guys. So feel free to do that, guys. Just yeah, feel free to use the chat as you may wish. So yeah. So let me just share my screen then, I guess, so that we can start discussing the problem statements. So yeah, I'll just share my screen. Okay. Okay. Yeah. So I hope my screen is visible to everyone. In case it is not, then you can inform me via chat. So yeah, if you don't inform, I'll just be assuming that it is visible to everyone. And if you don't ask in doubts, I'll be assuming that the solution which I discuss is also clear to everyone. So yeah, so I prepared basically a bunch of 10 problem based on permutations combinations. So yeah, I guess we can get start discussing these one by one. So the first problem is in how many ways the word pathogen can be arranged such that the letter O always comes to the left of T. So the problem statement asks in how many ways the word pathogen can be arranged so that the letter O always comes to the left. So to the left means that it can be anywhere to the left of the, it need not be immediately left. It can be to any side, like it can be any distance away. It just needs to be left of D. So any ideas, guys? Like, would any of you like to answer what should be the answer to this question? Like, I think this is a very this is a type of problem which we might also have done in high school. So yeah, would any of you like to answer this in chat? Okay, I guess I should start discussing in that case. So first of all, let's just see in how many words this in how many ways this word pathogen can actually be arranged. So see, let's just see what this pathogen word looks like. So pathogen has these Pathogen. So there are 8 alphabets in this word pathogen. So the word pathogen has 8 alphabets, and all of these are distinct. So being distinct is also important because we always, if there are two same words, let's say there were two E's or there were two O's, then we'll need to avoid repetitions also. So we'll need to account for repetitions in that case also. So in this case, the word pathogen has 8 distinct characters. So the number of ways in which pathogen can be arranged is nothing but just permuting these 8 characters as we wish. So there are 8 characters and we need to permute them. So there are 8 factorial ways uh, uh, to, uh, to arrange the word characters of the word pathogen. But now what we actually want is that the letter O should always come to the left of T. So we need to, out of these 8 factorial words, 8 factorial possible permutations, we need to count the number of permutations in which O always comes to the left of T. So there are two possible ways actually in the permutations. Permutations of pathogen. there are two possible ways. Uh, first is O comes to the left of T, and second is easily O comes to the right of T. And note that the number of cases in both of these would be equal. Actually, the number of permutations of pathogen in which O comes to the left of T will actually be equal to the number of permutation in which O comes to the right of T. And why is that? Because for any permutation in which O comes to the left of T, you can just swap T and O with each other, and you will obtain a permutation in which O comes to the right of T. So I hope what I said is clear to everyone. So what I'm saying is the number of permutations of this kind will be equal to number of permutations of this kind. So what this actually means is that number of ways in which uh, or maybe I can just say let number of permutations in which O comes to the left of T in which O comes to the left of T. Let us assume that this number is equal to X. Then we know that then number of permutations in which O comes to the right of T will also be equal to X. So O comes to the right of T will also be nothing but X. And we know that in any permutation of this word pathogen, there will only be two possible cases, right? Either O comes to the left of T or O comes to the right of T. So what we can actually claim is, so X plus X is nothing but the total number of possible permutations, which is nothing but 8 factorial. So X plus X is equal to 8 factorial. And this implies that 2x is, so this implies that 2x is 8 factorial. And so this gives us as x equals 8 factorial divided by 2. And this will be our answer. So I'll just underline this to show that this is the answer for us. That is number of permutations in of pathogen in which O always comes to the left of T is equal to 8 factorial by 2. So yeah, I guess it's straightforward. So maybe just based on this question, let us ask another question. So here, the problem became easier because the word pathogen contained actually 8 distinct characters. So what we just needed to do was just count out total permutations, which are 8 factorial, and just divide it by 2 to obtain our answer. So let us ask this problem now. So maybe not alternate, but yeah. So maybe just I'll write another problem. So another problem of this type. So let us say the problem now states that in how many ways the word instead of pathogen, let's say I replace this word pathogen by, let's say, my name. So my name is Lakshay. So in how many ways the word Lakshay can be arranged such that, so note that in Lakshay there are two A's, right? And every other character occurs once, but A occurs twice. So let's say I say that in how many ways the word Lakshay can be arranged such that the letter Y always comes to the left of both the A's. So Lakshay has two A's and this one Y, and I want to obtain the number of permutations in which this word can be arranged such that the letter Y always comes to the left of both the A's. So in this, like in this permutation, this Lakshay permutation, both the A's come to the left of Y. But what we actually want is something like Y coming to left of both the A's. So a permutation in which Y comes at the first and these two A's come at the last will be a type of permutation which we'll want. So would anyone like to think about this problem? Like how will we approach this? So approach will be similar to this, but there will be a slight change because now we have repetitions of the characters, right? So here what we'll do is okay. So total number of ways. So here we know that total number of ways in which Lakshay can be arranged is equals to. So in how many ways? So what are the total possible permutations for this word? So there are, I see that there are 1, 2, 3, 4, 5, 6, 7 characters in this word in my name, but there are, but here they are not distinct. There are actually two ways. So total number of ways in which this word can be arranged. What will be this value? So Ojas is typing something in chat. Okay. So Ojas is saying that the number of ways in which Lakshay can be arranged is 6 factorial. So this is according to Ojas. So, so would anyone like to comment on this? Is this correct or is this incorrect? Like saying that the number of ways in which Lakshay can be arranged is 6 factorial. Is this correct or incorrect? Okay, maybe I should answer it. So it's close to the correct answer, but not exactly. So the answer to this should be actually 7 factorial by 2. And why is this the case? This is because note that there are 7 characters here in the word Lakshay, right? So if these A's were distinct, then there would be 7 factorial ways to permute this word, right? So there will be 7 factorial ways if these A's were distinct. But since these two A's are not distinct, so what will happen is, so there will be one permutation. So there will be actually two permutations which will correspond to the, so out of the 7 factorial, there will be two permutations always which correspond to actually the same word. So let's just take this word Lakshay itself. So maybe let me call this A as A1 and this A as maybe A2. So these are different A's, right? So this is one possible permutation of these 7 characters. Another possible permutation of these 7 characters could be this one, in which this A2 comes first and this A1 comes second. But we know that this also corresponds to Lakshay itself, right? So maybe I should mention this, that we are asking for distinct ways, right? We are always asking for distinct ways. Otherwise, it doesn't make sense, right? So if this A1 was first and this A2 was second, and in the second permutation, this A2 was first and this A1 was second, we were obtaining the same word nonetheless. We were obtaining the word Lakshay itself. So actually, these two permutations are same for us. So note that you can always swap the two ways with each other. So there will always exist two permutations. So let's, for example, let's say there is another permutation, this one, LAA So here also there will be one permutation in which this will be A1 and this will be A2. And there will be another permutation in which this will be A1 and this will be A2. So, but the actual word which we have is only one for both of these permutations, which is this. So what we'll actually need to do is we'll need to divide by this 7 factorial, we'll need to divide by 2. And why are we dividing by 2? Because this A2, A1. So in all ways, this A1 and this A2 can be exchanged with each other and they'll still give us the same name. So in this 7 factorial, we are counting each of the word twice. So we'll need 7 factorial by 2. the number of ways in which Lakshya can be arranged. So is this clear to you, or just like why is 6 factorial not the correct answer, but 7 factorial by 2? I assume you just counted the number of distinct possible characters which are here, like 6, LAKSHY. But note that these two ways, even though they are not distinct, but this does not mean that the answer will be 6 factorial. Okay, so Ojas says that it's clear to him. Nice. Okay. So the number of distinct ways in which Lakshya can be arranged, we have now obtained that it will be 7 factorial by 2. So we know that the number of ways in which Lakshya will be arranged is 7 factorial by 2. But note that this is not what we wanted. The question was the word can be arranged such that letter Y always comes to the left of both the A's. Right? So note that consider any possible permutation. Any possible permutation. Then there will be, so here there were two possible ways earlier in pathogen that O comes to left of T or O comes to right of T. Similarly, in this permutation of Lakshya, there will be three possible ways. And what will be these three possible ways? I'm claiming that these three possible ways will be uh, something like this, that so there are these two A's and this Y, and we need that this Y should come before these two A's, right? Comes to the left of these two A's. So one will be where, so one possible permutation will be where this Y actually comes before both of these A's. The second set of, and like all the alphabets come in between or somewhere, but at least the ordering between these Y's and A's is such that the Y comes to the left of both the A's. Another possible ordering can be in which Y comes between the two A's, and another possible ordering can be in which Y comes to right of the two A's. So there is no other possible ordering. And note that we have in this, while dividing this 7 factorial by 2, we have already accounted for the fact that these two A's are not distinct, right? So here also these two A's are not distinct. So we won't write Y A1 A2 and Y A2 A1 as two different ways. Since these two A's are the same, so we'll have to write it something like this, that this Y, then this, then two A's, or just A, or just A, Y. So these are the three possible ways. In any permutation of Lakshya, either Y will be to the left of both A's, or it will be between the two A's, or it will be to the right of the two A's. There's no other possible way, right? And again, we note that like these permutations will be equal in number. And why is this the case? Because in any permutation in which Y comes before the two A's, what one can do is okay. So what one can do is maybe swap this YAA with this AYA, and rest of the permutation remains the same. So this Y will be replaced by an A, this A will be replaced by a Y, and this A stays as the same. So that's why these two will be equal. Similarly, like this AYA can be replaced by AAY, and rest of the permutation remains the same. So what we'll actually obtain is, so what we can actually say is all these three possible permutations will be equal in number, because this possible ordering can be replaced by this ordering, and rest of the things will remain the same anyways. So I hope this makes sense to everyone. So what this means is that let number of permutations in which let's say let number of permutations in which Y comes to the left of both the A's, let's say this is equal to X. then we know that this AYA and this AAY is also X. So then we say that X plus, so in any permutation, so all possible permutations will be made up of this, and this. So X plus X should be equal to the total number of permutations. And what are the total number of permutations? It is something like this, the 7 factorial by 2, right? So it is 7 factorial divided by 2. So this implies, uh, so this what this gives us is that 3x equals to 7 factorial by 2. So x will be nothing but 7 factorial by 6. And you can just count it. You can just calculate what this value is. So I hope this argument makes sense. Like, how did we arrive at this? So we just first counted the number of distinct ways in which function can be arranged. And then we just saw that any permutation has three possible ways, and these possible ways will be equal in number because one set of this can be replaced by this set, and this can be replaced by this, and so on. So I hope this is clear to everyone. I think I let do this, but yeah. So if there are no questions in chat about this, then maybe we can move on to the next question. I think by mistake I had left its answer as written, but maybe I'll just. So now the second question is somewhat similar to the first question, but now it just asks us in how many ways the word pathogen can be arranged such that the letter O always comes to the immediate left of T. Note that in the original problem, what we had asked was that O always comes to the left of T. And there we had said the argument will be something like O comes to the left of T and O comes to the right of T will be equal. And so the answer will be total possible permutation divided by 2. But here we are saying that in how many ways the word pathogen can be arranged such that O always comes to the immediate left. So what this means is that this thing, this word OT should occur together actually. So this O with T should occur together. So would anyone like to answer this now? Like, I mean, in how many ways will this happen that OT will occur together? Okay, who just is, I think, answering this in chat. Okay, Ojas. So Ojas is saying that the answer should be 7 factorial here. So does anyone have any comments on this, whether the answer should be 7 factorial or not? Okay. So yes, Ojas, actually your answer is correct. So what will happen here is so now actually since O and T should occur together, we can think of this OT as a single character. So this is not like this is the we can treat it OT as a special character, which is actually consists of two words, two alphabets, but it is a single character because it will always occur as OT only. It is not breakable. So what this means is that now we have 7 distinct characters for permutation. And what are these 7 distinct characters? They are just P, A, H, G, E, N, and O, T. So these are the 7 distinct characters, and they can be arranged in any manner. And in all of these permutations, the word letter O will always come to the immediate left of T. So these are 7. So number of permutations is equals to 7. Yeah. So good job, Ojas. So the answer here should be 7 factorial. So yeah. So after this, if there are no doubts, then maybe we can move on to the third question. So third question says that Rahul has 7 differently colored shirts, 5 different jeans, 2 pairs of shoes, and 3 different caps. In how many ways can Rahul dress up before going to a party? So I think this is an easier question than the previous one. So would any of you like to answer this? Okay, we just is again typing. Okay, so Ojas is saying that the answer should be 210. So yeah, like maybe I should break it down for you, but yeah. So the answer is correct actually, which is that the answer is 210. So what we have with us is that we know that the number of shirts is some. So let's just write down what the shirts and the number of jeans the given was. So jeans, shoes, caps. So we know that we have 7 shirts, we have 5 jeans, we have 2 pair of shoes, and we have 3 caps. So what this means is, uh, so what this actually means is, for dressing up to a party, let's assume that Rahul will always be so Rahul does not have an option of like going shirtless or going jeanless. So we'll assume that Rahul is a decent gentleman who will wear a shirt and jean as well as shoes and caps. So for wearing shirt, Rahul has 7 ways because there are 7 distinct shirts. So out of these 7 different shirts, Rahul has to choose one shirt. So Rahul has 7C1 ways. So 7C, so this 7C1 just means 7 choose one, or like this is just the symbol for combination, right? So the permutations and permutation are denoted by P and combination are denoted by C. So Rahul has 7 choose one ways to wear a shirt. Similarly, he has 5 different genes and he has to select one gene. So he has 5 choose one ways to wear a gene. Similarly, out of 2 shoes, 2 pair of shoes, Rahul will have to choose one pair. We'll assume that Rahul won't uh, wear one shoe of one color and another shoe of other color. So yeah. And again, out of 3 different caps, Rahul will have to wear one cap. And so this will be the answer. And this is just like 7 choose one is 7, 5 choose one is 5, 2 choose one 2, 3 choose one 3. So this is 7 into 5 into 2 into 3. 2 into 3. And this will come out to be, if you do the calculations, this will come out to be something like 210. So yeah, that's the answer. So I'll just underline it. Good job, Ojas. So yeah, not too difficult, but yeah. Let's assume. So here we had that Rahul should wear one of everything, right? Should wear at least one of everything. And in that case, we had arrived at uh, this answer, right? Uh, but let's just assume that there was an alternate question. So what if Rahul is allowed to wear no cap? So Rahul also, so while here we as so note that while counting the number of ways here we assume that Rahul will wear one of everything. So Rahul will wear one shirt, one jean, one shoes, and one cap. But what if we also give the Rahul the option that, oh, maybe you don't like caps, so you want to front your hairstyle, so You also have the option to not wear any cap. So in this case, uh, how will the solution change? Okay, so Isha and Ojas are typing. Okay. So there are two messages from Nikhil and Isha. So maybe I'll answer the question of Isha first, and Nikhil, I'll come to your question second. So Isha is saying that in which question we need to use permutation and in which question combination. How can we know that? So Isha, knowing that, so actually you need to go to the definitions of combinations and permutations, right? So maybe I'll just uh, go here and maybe, okay, sorry for this. Oh my God, what's happening? Yeah. So maybe I'll just define the combination and permutation for you. So what is permutation and combination? And this will hopefully clear up things for you. So combination just means, so let's say I denote it by something like N choose R. So what this means is, what the hell is it? So this just means, if my keyboard is doing weird things, I don't know why. Selecting R objects from N different objects. So what does a combination mean? It just means that uh, let us think of this as a base case definition, that if we need to select R objects from N different objects, then this is what we call a combination. Okay. And let us assume that, let's for now just assume that we know that its formula is given by N factorial divided by R factor, N minus R factorial times R factorial, N minus R factorial and R factorial. So let's just assume we know this. I'll come back to this. Like, why do we know this? But let's just say we know that combination means that selecting R objects from N different objects. And this is what we call this. And what does permutation mean? Permutation is denoted by NPR. And this is denoted by NPR. And this is selecting and then arranging. So that here in combination, we just wanted to select objects. We did not bother about their ordering, like in which order should they be present. But in permutations, what we want is we want to select the objects, but then we also want to arrange the objects. So arrange is the keyword in permutations, arranging our objects from n different objects. So how do we select and then arrange? So let's say we want to find out what's the formula for this NPR. So it will hopefully be clear to you guys. So we want to select and then arrange, right? So first of all, we can select in n choose R base, right? If we want to select our objects, I can just do it in n choose R. So I first select, let's say I first select in n choose R base. And I have select. So now after this step, I have selected R objects, right? From the given n objects, I have selected R objects. But now I also want to arrange these objects. So note that what this means is that suppose I was given numbers 1 to n. Out of these, I have chosen R distinct numbers right now. But right now, I don't care about their orders. If I have chosen, let's say, numbers 1, 2, 3 till R, I don't care in which order they occur. But in permutations, we also need to specify the order in which they occur. Like we also, so like let's say the numbers I chose, let's say R was only 2, so the numbers I chose was only 1 and 2. So I selected the numbers 1 and 2. But while arranging, what I can do is I can write it as 1, comma 2. I can also write it as 2, comma 1. So there are two different ways of arranging. Even though the selection was only 1, comma 2, but this selection of 1, comma 2 can be arranged in two different ways. It can be arranged as 1, comma 2. It can also be arranged as 2, comma 1. So similarly, if we are given R objects, then these R objects can be basically ordered in R factorial ways. So so the formula for permutation will be nothing but n choose R times R factorial. And if you plug this in, then it just comes to like n factorial divided by R factorial minus R factorial into R factorial. So this will come out to be nothing but n factorial divided by n minus R factorial. So I hope at least what I discussed right now is clear to you, Isha. Uh, uh, does it make sense? Like selection and arrangement, how do these differ? Okay, Isha is typing something in chat. Okay, so you understood. Nice. So just for the sake of completeness, maybe just uh, okay. So maybe just let's just derive this formula n factorial by n minus r factorial. So while deriving this formula, what I said was that let's assume that n choose r is given as this. But let's say I just wanted to derive as it is. Like how do I say that permutation or NPR is equal to n factorial divided by r n minus r factorial? So one way to look at it is so I want to arrange r objects, right? So what this means is I have n objects. Okay, yeah, I have n objects and I have r spaces. So I have r blanks, let's say, and I want to put these objects in blanks. So what I have is, let's say I have these r blanks, something like this. So let's say these are the r blanks and so on. And I have n objects, right? And I want to fill these blanks. So what will happen is while filling up the first blank, there were n objects. So out of those n objects, I could have filled this blank with any of those objects, right? So there were n choices for us while filling out this blank. So, so while filling out first blank, we have n choices. While coming to the second blank, what will happen is while filling out the second blank, uh, so suppose we are filling in this order, like we are filling first, we are filling second, we are filling third, and so on till rth. So while filling first blank, I had n choices. I could choose any of the objects since none of the objects was chosen. But while filling the second blank, what's going to happen is I would have already chosen one of the objects. I don't know which object, but I'm sure exactly one object would have been chosen in the first blank. So while filling the second blank, there will only be n minus 1 choices left. While filling the third blank, similarly, there will be n minus 2 choices left because first and second would have taken exactly two objects. I don't know which two, but I'm sure there will be two. And this will happen. And while filling out the rth blank, what's going to happen is last r minus 1 choices would have been filled. So I would be left with n minus r minus 1 choices. And what's the total number of ways then? So total number of ways of filling out these blanks is just the product of these. And why is it a product? Because so why are we doing a product and why are we not adding or something? Someone may have this kind of doubt in mind. So note that this is because these all these the entries of all these blanks are somewhat independent, and like if I have an entry here, let's say I have an entry of 1 in the first blank, then the second blank I can have any of the entries from 2 to n, and all of these will be different answers for me, right? So that's why uh, maybe I'm not sure if I put it correctly, but yeah. So if this has, let's say, n choices, so suppose suppose this blank was filled with 1. I filled this blank with 1. In that case, I can fill this blank with 2 to n minus 1, any of those. So there are n minus 1 choices for the second blank, given that I filled the first blank with 1. So, but if I had filled the first blank with instead the number 2, then also second blank would have n minus 1 choices. And these two will be distinct cases. So similarly, there are n choices for the first blank, and in all of these cases, there will be n minus 1 choices for the second blank. So the total number will be something like n times n minus 1, if this makes sense. So actually, the total number of ways in which this can be filled will just be product of these n minus 1, n minus 2, n minus r minus 1. So total number of ways is nothing but n times n minus 1 times n minus 2 and so on. N minus r plus 1. And this is nothing but if you multiply and divide this by n minus r factorial, then you will just get this. So this is nothing but the actual value of n. So yeah. So just a reminder, like how do these permutations and combination formula actually come about? So selection, whenever we have to just select, we choose this NCR. Whenever we have to permute, we choose NPR. So for example, here in how many words the pathogen can be arranged. So we had to arrange the words of the pathogen, right? So order also mattered. That's why we use this 8 factorial, or we just use permutations. We did not talk about like combinations here because arrangements were important. Similarly, in second question also arrangements were important. In third question, we use combinations, and why is that? Because we are not arranging anything, right? We have to just select one shirt. Note that while getting ready, you select one shirt, you select one jean, you select one pair of shoes, and you select one cap. So that's why here we are just selecting. And that's why instead of writing it down as there are just 7 into 5 into 2 into 3, I like to write it down this way. Because then it becomes clear that what we are actually doing is we are just selecting one out of these two things. And so that's why in the third question, we use something like combinations. Okay, so I hope this answers Isha's query. If you want to know more, feel free to ask in chat. Otherwise, so now I'll come to now Nikhil's comment. Uh, so, so I had given this alternate question: what if Rahul is also allowed to wear no cap? So there's a follow-up question by Ojas also for this. In the alternate question, is that case valid to in which Rahul wears cap? So yes, Ojas, that case is also valid. And I think this was maybe not clear from my side, and that's why Nikhil gave the answer as something like 70. But note that here what we are doing is the problem states that what if Rahul is also allowed to wear no cap? So either Rahul has a choice of wearing one of these three caps, or Rahul also has another option in the caps department, which is to wear no cap actually. So no cap is not actually a cap, but so in the caps department, like in the shirt header, Rahul still has 7 choices to wear shirts. In jeans, Rahul still has 5 choices. For shoes, Rahul still has 2 choices. But for caps now, Rahul has 4 choices because no cap is also a choice under caps header, right? So what this means is that, so in this case, the answer will become something like, so now the caps become actually 4. So because you can think of no cap as also a cap, right? And in that case, this will become 7 times 4 choose 1. And this will become something like 280 in that case. So an alternate way to see this is like, if it is not clear to you, why did I just do this caps as 4, and uh, if we are not allowed to be a cap, why is that also a cap or something? So you can just think of these as two cases also. Uh, Another way to look at it is, another way is to divide this into two cases. And case one is Rahul is wearing a cap. So in Rahul's final outfit, Rahul is wearing a cap. And in that case, we already know the answer is 210, right? We had already solved that. If Rahul is wearing a cap, then there are 210 ways. And case two is, suppose Rahul does not wear a cap. And in that case, the choice for Rahul is only for shirts, jeans, and shoes. Since Rahul is not wearing a cap, we'll ignore this column. So there are 7 ways to choose a shirt, 5 ways to choose jeans, 2 ways to choose shoes. So this will be nothing like 7 into 5 into 2. Okay, yeah. And this will come out to be 17. So there are 70 ways for Rahul to not wear a cap. And if Rahul is wearing a cap, then there are 210 ways. Since these two cases are disjoint, so we can just add them up to find out total number of ways. So total number of ways is 210 plus 70, which is 280. So I hope this makes sense to everyone. So yeah. So this is just a alternate formulation, like dividing into cases makes it a bit longer. But I think it's, at least in permutation combination, it's good to look at the same problem using many different arguments, because this helps us understand the concepts better for permutations and combinations. Okay. So let's come to the fourth question. So yeah. So now this question says that in how many ways can the word documentation be arranged so that all the consonants come together? So now this is an interesting question. So I would like that you guys try it yourself first, because this is again a bit of a conceptual question and it will require some understanding. Right? Maybe I'll give you guys 2 minutes to try this out. Okay, so Ojas and Nikhil already have answered to this. So it's like already have answered this in chat. So the Ojas is saying that the answer should be 7 factorial by 2 times 7 factorial by 2, whereas Nikhil is saying 7 factorial to 7 factorial. Okay, so Ojas and Nikhil both are giving different answers. So guys, I'll give you, so it's 6:57 right now. I'll give you 3 minutes. Like by 7 p.m. Like uh, think about it a little more, and answer it in chat. Like not just Ojas and Nikhil, if anyone else also wants to answer, like Isha or Malvika, if you guys also want to try, just type in chat. I'll give you 2-3 minutes to think about it. So yeah, I'm muting myself for 3 minutes and you guys think about it. So I'll give you a hint that neither Ojas nor Nikhil have like are correct. So both of these answers have some mistakes. So keeping this in mind, maybe use the Nikhil, you can also think about it again. Okay, so I guess what has written like another answer 6 factorial by 2 times 7 factorial by 2. So that is also not quite correct. But yeah, I believe Ojas was the closest to the correct answer. So maybe we'll figure out what's the correct answer while discussing this. Right. So the question says that in how many ways the word documentation can be arranged so that all the consonants come together. So first of all, whenever this type of question comes, we first count how many distinct characters are there for us. Like first of all, let's just do that and also like divide into consonants and vowels. Everyone knows what vowels are, right? A, E, I, O, U are vowels. Everything else is a consonant. So let's just write down the consonants first. So what are the consonants in this? So The consonants are this D, C. So maybe I'll just write down D, C, M, N, T, T, O, N. So there are two T's. So I'll just write down first as is, and then we'll see what to do with these two T's. And then there's this N. So these are the consonants. And let's write down the vowels. So what are the vowels in this? So this O, this U, this E, O, U, E, A, I, O, A, I, O. Yes. So there should be 1, 2, 3, 4, 5, 6, 7. There's 1, 2, 3, 4, 5, 6. So yeah. So these are the vowels, these are the consonants, right? And now maybe just try to write these down as in form of like how many of these are there. So there is only one D, there is one C, there is one M, one N, two T's. Okay, so there are two N's and two T's. Okay, so maybe I should just write it down properly. So there is one D, right? And there is one C, because there is only one C. There is one M, there are two N's, and there are two T's. So this is the description of the consonants. And what's the description of the vowels? So vowels is two O's, one U, one E, one A, one I. So I hope everyone is following along with me. Like I'm just breaking this down. Like these vowels have these characters and these consonants have these characters. So note that now what the problem statement wants us is that all the consonants should come together. So problem statement is that so vowels need not come together. Vowels can be separated or any way they want, but the consonants should always be coming together. So what this means is that we'll need, so these characters should be occurring together actually. In the permutation which we want, these characters should be occurring together. We'll need these to occur together, but they can be permuted amongst themselves. Note that we do want all of these DC, MN, TTN to occur together, but it's not necessary that they should specifically occur in this order itself, right? The order can be anything like MCD, NTTN, or any order will suffice, right? We just want that they should occur together, but they can then be permuted amongst themselves. There is no restriction on the permutations. The only restriction is that they will occur together. And for vowels, I believe there is no restriction, right? So now let's just number of ways of. So now let's just find out like in how many ways can these actually be permuted amongst each other. So what we want is, so let's just look at a high level picture first. So we'll be permuting these consonants amongst themselves. And then every permutation in like all of these permutations, like this will occur as a single word. Like since all of these should occur together, any permutation of these will occur together as a single character. And it will be permuted with the set of these vowels. So this is the high level picture which we'll be following. So now number of ways of. So first of all, let's find out number of ways of ordering consonants. So in which order will they occur, right? It can be D, C, M, N, T, T, N, or it can be D, N, C, T, T, N, or something like these. So in how many ways can we order these? So let's just do it step by step, guys. So we'll have better understanding. So in how many ways can these consonants be ordered? I have also broken it down for you that these are written as this. So first answer this in chat. Okay, so just is saying that the answer should be 6 factorial by 4. So I think I think you are doing mistake again, like a similar mistake to what you are doing earlier also. So note that there are 1, 2, 3. 5, and 7. So there are 7 consonants. And out of these 7 consonants, there are 2 repetitions of n and 2 repetition of t. So actually number of ways of ordering this is actually 7 factorial divided by 2 factorial times 2 factorial. Like, and why is this? So I think it can be easily derived like from these concepts which I've already discussed previously. That if we want to find out, let's say, number of orderings where, like, let's say there are total of n objects, but n1 are of the same type, n2 are of the second type, and 3 are of the third type. Then the number of ways of ordering them is something like n factorial divided by n1 factorial, n2 factorial, n3 factorial, and so on. This is not very difficult to prove. It can be proved easily. So there are here 7 objects. There are 2 t's, 2 n's. So these are 4, 5, 6, and 7. There are 7 consonants, and there are 2 n's and 2 t's. So there are 2 objects of type or like of counts 2, and others have like only 1 occurrence. So we'll need to divide 7 factorial by 2 factorial corresponding to this 2 n's, and then another 2 factorial corresponding to these 2 t's. So that's why this will be 7 factorial by 2 factorial times 2 factorial. Does this make sense? Or just this is similar to what we did here. Here we said that the number of ways in which Lakshya can be arranged is 7 factorial by 2. So we took all the characters, there are 7 characters, and there is only 2 A's. So we divide by something like a 2 factorial. Similarly, here there are 2 N's and 2 T's. So we divide by 2 factorials. These are some of the uh, basic things which you guys should be clear with. So if it is not clear, then definitely ask. I'll try to explain this again. That why is this correct? That this should be 7 factorial by 2 factorial, 2 factorial. So there originally were 7 factorial orderings possible if all of these were distinct. But let's say since these 2 t's are the same, so we'll need to divide this by 2 factorial. And similarly, 2 n's are same, so we'll need to divide by further 2 factorial. So at least number of ways of ordering consonants will be this. Okay, Nikhil is typing something in chat. Okay, Nikhil will come to the answer later. I think you have got the correct answer, but yeah, I'll just come to this answer again. So number of ways of ordering consonants, at least let's just first be clear with this, that till now everyone should be able to understand like why is this the case. So again, Isha just want to point out that I just want to point out that here also we are doing permutations because again we are talking about orderings here. We are not talking about just selections. We are talking about orderings. Okay, so this is the first step, but this is not the final answer. So we have just ordered the consonants right now in this much ways, but there are vowels also, and we want actually the number of permutations in which all the consonants actually come together. So all the consonants will come together. So we'll have to permute. So what we'll have to do is the total number of ways will be nothing but what we'll be doing is we know that we have these much vowels, but now we also have another character. Like in the final answer to find out the total number of arrangements, what we were sort of doing is we first find out the number of ways of ordering consonants, and now what we are trying to do is we'll keep all these consonants together, right? So all these consonants will occur together, so they can be thought of as a single character, even though they consist of multiple alphabets. But this set of consonants will be occurring together, and so they can be thought of as a single character. So the total number of ways will be nothing but total number of ways of commuting this consonant as a single character. So I am denoting by parentheses that the set is a single character. And then these two O's, one U, one E. This. So we are commuting this along with these two O's, one U, one E, one A, and one I. And this will be our final answer. And why is this the case? Uh, because, yeah, and we'll also like, so first of all, we choose the order for the consonants. So first of all, we choose number of ways of ordering consonants. And then we sort of, when an order is fixed, what we'll do is we'll take these consonants together as a single character and these two O's, one U, one E, one A, one I, and permute this single character with all of these forwards. So I hope this is clear. So let's just count this part first. So what will this be equal to? So let's just find out the number of characters in this. So it will be, this constant will be a single character, then two O's, so total is 3, 4, 5, 6, and 7. So there are 7 total characters. So maybe I'll just, it's here. So this will be nothing but, so there are 7 characters, consonants is a single character, then there are two O's, so this becomes 3, 1 plus 2, then 1 U, so 3 plus 1, 4, 5, 6, and 7. There are total 7 characters. And out of these there are two O's and everything else is non-repeating. So there's only one set of such consonants. There's one E, one U, one A, one I. So we'll just need to divide this by 2 factorial. So I hope this part is clear, that total number of ways of commuting considering consonants as a single character will be something like this, 7 factorial by 2 factorial. And now the total number of ways will actually be, we'll first fix an order of the consonants. So since there are multiple possible orderings, and in any such ordering, we'll obtain 7 factorial by 2 factorial base of commuting. So this is the answer. So the final answer will be something like number of ways of ordering consonants, which will be 7 factorial by 2 factorial times 2 factorial. And this is multiplied by 7 factorial by 2 factorial. This part. So for Nikhila, so this is the final answer. Something like a 7 factorial divided by 4 times 7 factorial divided by 2. And this is what like Nikhil has written finally. So yeah, good job, Nikhil. You figured it out in the end. But yeah. Okay, so Nikhil is asking where can we access recording of this session. So Nikhil, after this session gets over, I'll by tonight or maybe by tomorrow morning, I'll post the, most probably by tonight, I'll post the YouTube playlist link where I'll be uploading these sessions. So in that playlist, week by week, I'll keep uploading these sessions as we go along. So yeah. So in this Teams chat only, I'll be uploading that link. So yeah. So I hope this is clear to everyone. Like this was one of the most interesting questions of this problem solving session. So I hope you guys understood this, because this is a bit tricky because we have to first see ordering consonants and then consider consonants as a single character and so on. But yeah, this is a good exercise for understanding permutations and combinations. I just underline this to show that this is the final answer. Okay. Maybe. Okay, Nikhil is typing something in chat. Okay, Nikhil, maybe uh, uh, I haven't I haven't recorded any session 3 days back. So So I'll only upload the sessions which I am doing. So the others you'll have to ask others about the links for their sessions. I can only inform you about the sessions which I am taking and I'll be uploading them. So this is my first session. So I don't know about the session 3 days back or something. So yeah. So yeah, maybe keeping these administrative doubts aside, if someone has any doubts in the solution which we discussed, like feel free to ask. Otherwise, I'll just move on to the next question. So, Ojas, do you see why will this term be 7 factorial by 4, not 5 factorial by 4? Is it clear? Okay, it's clear. Thanks. Yeah. Because yeah, like a lot of questions here like are not that interesting, but this was one of the most interesting questions. So I would like even if I don't cover the remaining questions, I would like you guys to understand this at the expense of not doing other questions. I don't mind skipping some. But yeah, if everyone says that they have understood, then okay, what just happened? Okay, I think my Chrome crashed or something. Sorry guys, I'll just share this again. Okay, yeah, I hope my screen is visible again. So so let's just start with the answer for the fifth question. It's not too difficult, I think. So fifth question says that a question paper consists of 20 questions having two parts. Each part consists of 10 questions. Students have to answer 12 questions in total, of which at least 4 questions should be from part 1 and 4 questions should be from part 2. In how many ways can the student select questions? So in this problem, Isha, you should note that we are just selecting questions. Students, in how many ways should students select questions? There is no particular order which student has to apply on the questions. A student has just to select the questions and nothing else. So here we'll be using uh, combinations and not computations. So just a heads up, nothing else. So so what the problem statement says is that there are 20 questions and part 1 has 10 questions. Part 2 has part 2 also has 10 questions. And what we need is to attempt 12 questions. We need to attempt 12 questions and such that 4 questions from part 1 and at least 4 questions. Okay, what's this? 4 questions from part 2. So this is the problem statement, right? Problem is saying that paper are 20 questions having 2 parts. Each part consists of 10 questions. Students have to answer 12 questions in total, of which at least 4 questions should be from part 1 and 4 questions should be from part 2. 20 questions, part 1 has 10, part 2 has 10, and we need to attempt total of 12 questions, exactly 12 questions. And the constraint is that we have to do at least 4 questions from part 1 and at least 4 questions from part 2. So there is no, so the straightforward way to do this is just forming cases. So case 1 will be something like, so maybe we can just write down these. How do we attempt these 12 questions? So these 12 questions can be attempted in many ways. So it can be like 4 from part 1, comma 8 from part 2. Like we need to answer 4 questions at least from both the parts. So we'll start with 4 from part 1. Or what can happen is we can answer 5 from part 1 and 7 from part 2. Or we can answer 6 from part 1 and 6 from part 2. Or we can answer 7 from part 1 and 5 from part 2. Or we can answer 8 from part 1 and 4 from part 2. So these are the only possible cases, right? For forming 12 questions such that 4 questions at least from both the parts. So this is the only way. Okay, so Isha is saying that she can't see the screen. Uh, can you still not see the screen, Isha? Okay, so you can see it now. Nice. So just Isha typing something in the chat. Okay, Isha. No issues. Yeah. So maybe we can continue with the solutions. So yeah. So either we can do 4 from part 1, 8 from part 2, 5 from part 1, 7 from part 2. So these are the only possible ways, right? So in case 1, suppose I'm doing 4 from part 1 and 8 from part 2. So what will be the number of ways to do this? The number of ways to do this will be, so part 1 has 10 questions, part 2 also has 10 questions. So we'll be doing something like, so we'll be selecting, so we just need to select, right? We don't need to order. So we'll be using combination. So we just select 4 questions out of the 10 questions from part 1. And similarly, we select 10. Similarly, we select 8 questions from part 2 out of the 10 questions. And note that since part 1 and part 2 are independent, we need to multiply the number of ways. So for this case, this will be the number of ways. So we'll choose 4 questions out of 10. Similarly, we'll choose from part 2 8 questions out of 10. And similarly, maybe I'll just copy paste this and take its values. So in case 2, this is the case 2, we'll need 5 from part 1 and 7 from part 2. Similarly, in case 3, we'll need 6 from part 1 and 6 from part 2. And in case 4, we'll need something like 5 from part 2 and 7 from part 1. So 5, 7, and similarly here, we'll need 8 from part 1. Okay, 8 from part 1, 4 from. And so the final answer will be nothing but sum of all the cases. So since all these cases are disjoint, so the final answer will just be the sum. Total answer is sum of cases. I hope this is clear to everyone. Okay, so Ojas is saying that okay, Nikhil is also saying that we need to add instead of multiply. I think for first we need to multiply and for second we need to add. So do you guys think what so Ojas and Nikhil, so do you guys think what I've written is correct or do you guys have some doubt in this? Okay. So Nikhil is saying that it's okay with him. Yes. Yes. So here we divided into cases. And since we divided into disjoint cases, so we'll add up all the cases. But while handling each of the case, we'll need to multiply. And that's what I'm doing. Okay. Good. So maybe we can just move on to the next question then. So the next question says that what is the coefficient of the sixth term in the expression 5x to the power 4 by 13 minus x cubed by 2 raised to the power 7. So here, I think it's just a binomial theorem related problem, and it's easy to see using permutation combinations also. But yeah, so note that uh, this definition, like saying that the coefficient of the sixth term. So note that sixth term definition is arbitrary, right? Like someone has to define what do you mean by sixth term, like sixth term from the start, the x to the power sixth term, or the x to the n minus sixth term, x to the power n minus sixth term, or something like this. So like what I'm saying is different terms here, like x to the power 1, x to the power 2, x to the power 3. Uh, all of these will have different coefficients, right? So x to the power 1 will have different coefficient, x to the power 2 will have different coefficient, x to the power 3 will have different coefficient, and so on. So uh, this sixth term definition is somewhat arbitrary. Like, what do you mean by sixth term? The x to the power sixth term or what term? So this is sort of something which you have to memorize. Like someone defines that we'll call the sixth term as this term, the term which is given, the term which is something like this, like n choose r minus 1. Like basically the term. So if we consider the first expression as a and second expression as b in the binomial expansion, then it is just n choose r minus, like the coefficient of the term which contains b to the power r minus 1. Maybe I'll write it down and it will be a bit more clear to everyone. So it's something like a to the power n minus r plus 1 and b to the power r minus 1. So something like this. So this is the definition of Rth term. And this is something which you will guys have to memorize, and there is no such straight thing because like this is sort of a conventional thing, right? That I'm defining the TRth term. Maybe I'll just put this like this to avoid confusion. Right. So this is n choose r minus 1. So the Rth term is just the coefficient of this term, a to the power n minus r plus 1, b to the power r minus 1. And for this term, like it's easy to see that its coefficient will be n choose r minus 1. This part is not difficult, but remembering that r term is the coefficient of this term is something which you'll have to memorize. So this is more of a formula based question, and this formula is more of a convention based thing and not maths based thing. So conventions you need to remember. You can't derive conventions, right? So this is the R term. So then I think the problem statement is pretty clear. Like here we'll just replace this a. So this is for a plus b raised to the power n, we define this dr, right? We define this dr as this. So here we know that this a is 5x to the power 4 by 13, and b is something like 5 by, so this is 5 by 13 x to the power 4. Maybe I should type this to avoid confusion. And similarly, b is nothing but b is nothing but minus 1 by 2 times x cubed. right? Because it's b is actually x cube minus x cube by 2. So b is something like this. And what we have is n we are given as 7. So so this n is 7 here, and r is nothing but 6. So just plug in the formulas and find that out. So note that finding the term or doing these calculations was not the aim of this problem. What I wanted to point out was that RA term is defined using convention. That the RA term, by RA term we mean the coefficient of this term, or by RA term we mean this term. So this is not mathematical, but convention based. So conventions you have to remember. Other things you can derive, but conventions are which was something certain person chose and everyone followed suit. So you'll have to follow suit also. Because like suppose in the exam or anywhere it's asked, like they'll just ask like what's the question of the eighth term? And you need to know like what do you mean by eighth term? So any RA term can be given. So, yeah. I hope this is clear to everyone. Then maybe we can move on to the next question. Okay, so Nikhil, do you have any question? I believe you are typing something in chat. Okay, so yeah, nice. So now maybe we can move on to the seventh question. Or I think these questions are a bit boring. Maybe I'll delete a bit few of these questions. Uh, yeah, yeah. Let's just do the seventh question first now. There are two vacant positions for the president and vice president of the club. The post can be given to any of the 50 members of a club, and a member can take more than one cabinet position. So, in how many ways can the two vacant positions be filled? So, would anyone like to answer this? So, yeah, like this is a straightforward question. So, Nicola answered it as 2500. So, yeah, while writing answers for permutation combination, I prefer to write it in terms of multiplication and not the final answer, because multiplications give you an idea of what's happening. So here what's going to happen is guys, the answer will be here something like 50 times 50. And why is this the case? Because there are 50 choices for the president, and and there are 50 choices for a vice president, because a person can take more than one cabinet position. So what can happen is from the 50 members of the club, like you can choose president and you can choose vice president also from 50 members. So this is the answer for this one, right? And what would have been the answer if a member can only take one cabinet position? If a member can take only one position. So I'm just discussing some variants for this. So in that case, the answer would have become something like so president position will have 50 choices, but as soon as someone becomes a president, uh, he or she can't become the vice president. So after choosing the president, there are only 49 choices left for the vice president. So the answer here would be something like 2450 if a member can only take one position. So yeah. Okay. So yeah, I think this is not too difficult to see. But maybe let me just present an alternate way of counting this. Like so what we just did was like 50 ways for president, 50 ways for vice president, and we were done. Similarly, 50 ways for president, 49 ways for vice president, and we were done. So I think this, what I'm going to explain is also going to clear up a bit of like when to use permutations or combinations, like what Isha had asked for earlier also. So uh, another way of counting this would be first, what we do is, so let's say the problem statement was this: if a member can only take one position, and we need to count this 2450 in an alternate manner. So what we can do is, first we select two people. So out of these 50 people, we know that we need one president and another as vice president. So out of these 50 people, we'll need to select two distinct people, right? First, we select two people from the 50. Then we make one of them as president and other as vice president, right? And let's suppose I count this as in this manner instead of the original manner where I just said that first place president has 50 choices and vice president has 49 choices. I say that I first select two people from the 50 and then I make one as president and another as vice president. This is also a valid way of counting. So how do I select two people from the 50? So if I'm just selecting two people, it will be nothing but 50 choose two, right? If I just first select. And after selecting, what I'm going to do is make one of them as president and other as vice president. So what's going to happen is, let's say I select two people, A and B. So now there are two ways for me. I can make A as president, B as vice president. Also, I can make A as vice president and B as president. Right? So there are two ways for me to choose between them as president as well as vice president. So the answer will be 50 choose 2 times 2, which will be nothing but which will be again equal to 15 to 49 only. You can see it by yourself. Yeah. So just presenting an alternate way of counting this. Like here, what we did was we just counted this using 50 times 49. But here we selected and then somewhat arranged them as VP and president. So like again, I just want to present another method or an alternate method for counting because this helps us uh, make our concepts a bit more clear. Okay. So after this, maybe we can come to the eighth question. I'll just put this in next page. Yeah. So eighth question says a bag contains five balls, five black balls, seven white balls, and nine red balls. The number of ways in which three balls can be drawn from the bag so that all of the three balls will have different colors is. So what we need to do is we have five black balls, seven white balls, and nine red balls. And we need to select three balls from the bag so that all three have different colors. So if all three have different colors, this means that one is black, one is white, and one is red. And note that we are just drawing the balls from the bag. Like we don't need any arrangements or anything, right? So what we want is draw three balls of different colors. And what this means is that one ball is red, or maybe one ball is black, one ball is white, and one ball is red. And how can we do this? So uh, out of these five balls, we'll select one ball. So this one ball out of these five balls can select in five choose one ways. And similarly, out of these seven white balls, I select one white ball. So this can be chosen in seven choose one ways. And similarly, out of the nine red balls, I'll be choosing one red ball. It can be chosen in nine choose one ways. So the answer to this will be something like 5 into 7 into 9. Right. I don't think it's too difficult to see, but yeah, Now let's formulate a different problem. Like we came at this problem. Okay, I hope this is clear to everyone. So, Nikhil, what you have written is, I believe, incorrect. So Nikhil is saying that 21 choose one, time 16 choose one, time 9 choose one. But I don't think this kind of works out. And uh, because actually, what I believe what you're written as 21 choose one is like you're choosing one ball. I believe what you're doing is you are choosing one ball from the total of these balls, and whatever the color of that ball, the remaining balls will should have been out of the 16 choices if the first ball was black, and then nine choices if the second ball was white. You're doing something like this, I believe. But uh, note that uh, your solution may cause repetition or it may choose more than one red ball at a time or something like that. So initially you're choosing one ball out of the 21 balls, and so the first ball can come out to be red. And now in the second ball, in the second choice you're choosing again from 16 choices, also come out to be red. So your solution would be like overcounting by quite a bit. Whereas here we just like one black, one white, one red. And this is what we arrive at. Okay, so you got it. So nice. So now, so the problem here was quite simple. Like it said that all three balls will have different colors. Now let's say I switch up the problem statement a bit. That uh, so three balls can be drawn so that I change this to at least two balls have different colors. So I give an alternate question. So here all three balls had different colors, right? Now what I'm saying is at least like I'm drawing three balls, but at least two balls should have different colors. Like if all three had different colors, then it was easy that one should be black, one should be white, one should be red. But now it's not clear. The colors may differ. Like two can be white and one can be red. That case also works for us. Or two can be black and one can be red. That case also works for us. And something like that. So one way of counting this is by dividing into cases that you take that all balls are of like two balls are of black and one ball is of red. Similarly, two balls are of white and one ball is of red. So you do all the at least two drawn balls will have different colors cases, and then you sum up all the cases. So one way to do it is that, but there is an alternate way which will be much easier for us, which will be like total number of. So what I do is I calculate its complement. Like let's say uh, if I have to draw three balls such that at least two balls have different colors, what this means is that like the negation of this will be something like if at least two balls don't have different colors, what this means is all three balls will have same color. What I claim is so what I'm trying to claim is total number of ways of drawing three balls minus number of ways of drawing all three balls of same color. So this will be equal to actually this. So you can do case work also, like I already told, like 2 black, 1 white, 2 red, 1 white, and so on. But it will be a bit more calculation. Whereas what I'm saying is at least two drawn balls, the negation of this, at least two drawn balls have different colors, will be that all balls have the same color. Because if any two balls don't have same color, then this means that there are at least two balls of different colors, right? So total number of ways of drawing three balls minus number of ways of drawing all three balls of same color. And now this can be calculated much easily. What's the total number of ways of drawing three balls now? Answer in chat, guys. In how many ways can I draw three balls from this set? Okay, since we have less time, so maybe I'll just answer this myself. So there are 5 plus 7, 12 plus 9, 21 balls, and out of those I have to select three balls. Note that I'm just drawing out balls. I'm not ordering them or anything. So I'll just be selecting them. So I have 21, choose three ways of drawing three balls, and number of ways of drawing all three balls of same color. So if all three balls are of same color, then there are three cases. All three are black, all three are white, or all three are red. So if all three are red, all three are black, then there are 5 black balls and I have to choose 3 of them. So it will be something like 5 choose 3. And okay, maybe I should write something like this. Plus, if all 3 are white, then there are 7 balls and I have to choose 3. So 7, it will be 7 choose 3. And similarly, if 9 are red and I have to select 3, it will be 9 choose 3. So something like this will be the answer. So the answer will be 21 choose 3 minus some of these things. So yeah, just underline this. Okay, so Nikhil is saying that we also need to remove the cases where all balls are of different colors. So good observation, Nikhil, but here the problem states at least two drawn balls have different colors. So the case where, so it's not saying exactly two balls should have different colors. It's saying at least two. So even if all balls are of different color, that also satisfies our condition, right? Yeah, that's a good observation again. Like I wrote it at least two precisely because I wanted this problem to become like this. So yeah, nice. So yes, so this is the answer for this type of question. So then maybe we can move on to the last question. So this is based a bit on the, this is not two different question, just based on like Catalan numbers. So yeah. So what we have to do is a total number of paths. What is the total number of paths from -3, -2 to 5, 6 without crossing the line, passing through -3, -2 and 5, 6. So just note that so we you guys must have seen the lecture. If you have not, just see the lecture about the Catalan numbers. So a Catalan number, so the Rth Catalan number basically tells us the number of ways for going from 0, 0 to a point r, r without crossing the diagonal, uh, passing from 0, 0 at r, r point. Something like this is given by the Rth Catalan number. So if you guys have not seen the lectures, I would recommend you guys because Catalan numbers are also very important counting objects and very cool also. So yeah. And after you've seen that lecture, I believe this problem will be fairly easy for you guys to follow. But what we actually have to do is, so here in the problem, we are not given that we are given that we are not starting from 0, 0, but instead from -3, -2. And we are going to 5, 6, not something like an r, r. But note that the trick in this problem is actually the origin is just a bit shifted. Actually, if you take this point as one point and this as the other point of the diagonal, this will still form vertices of a square. Like in x-axis, where what we need to move is like in x-axis, the distance of between these 2 points is something like a 5 minus -3, which is 8 units. Similarly, in y-axis also, The distance between these 2 points is something like 6 minus of minus 2. 6 minus of minus 2, which is again 8 units. So the distance in x and y axis is actually equal. So these points are actually corners of a square now also. Like even though we are not starting from origin, but if origin is shifted to something like this point, minus 3, minus 2, then we again arrive at this sort of thing, setting. Need to cover distance. This need to cover distance of this. So in fact, the problem just reduces to finding basically the rth Catalan number. So eighth Catalan number will be the answer for us now. So the problem reduces to finding the. So since the size of the square is like r cross r, like there's r length, the side length of the square is r, then the answer is rth Catalan number. And rth Catalan number is given by what I'll write down in the formula, but you guys should also note from the lecture. It is something like 2r choose r plus 1. Something like that. The problem is finding the number of paths from bottom left to top right point in a 8 cross 8 square grid without crossing the diagonal. And this is nothing but a 8th Catalan number. And this has been discussed in the lectures. And this, the value of 8th Catalan number is nothing but. So rth Catalan number is given by 2r choose r minus 2r choose r plus 1. I can write this down here also, but you guys should see the lecture of Catalan numbers. That is also a very important concept and will be asked in your quizzes also. Okay, 2r choose r minus 2r choose r plus 1. So something like this is the arithmetic. And its definition is something like this, like number of ways of finding the number of paths from bottom left to top right in a r plus r square grid without crossing the diagonal is what the rth Catalan number denotes. And this is nothing but so 2r choose r will be 16 choose 8 minus 16 choose, and it will come out to, I believe, something like 4862. This is the final answer, but yeah. Okay, so uh, so okay, so just so Nikhil is saying what is the formula. So I believe we just already provided the formula 2n choose n minus 2n choose n minus 1. So, yeah, this is what I have written also. So 2n 2r choose r minus. So Nikhil, you might be confused like why I've written r plus 1, but Ojas has written r minus 1. So note that 2r choose r plus 1 is actually equal to 2r choose r minus 1, right? Because NCR is equal to NC n minus r. So that's why both of these formulas are correct. Nikhil is typing something in chat. Okay, cool. So yeah, thanks for attending, Nikhil. So yeah, so I was just about to give closing remarks. Okay, so we're just typing something in the chat. Okay, so yeah. So I guess yeah, maybe I should give the closing remarks first, guys, before you guys start thanking me. So yeah, I guess this wraps up our problem solving session for today, guys. So there were 9 problems discussing various concepts. So I hope you guys enjoyed the session, and yeah, thanks for attending the session, guys. Hope to see you guys every week. So note that this week I took the session from Tuesday 6 to 8 p.m. But from next week onwards, it will be from on Mondays from 6 to 8 p.m. So yeah, the announcement will be made for you guys also, and I'll share the link of the recording of this session also in this chat. So yeah, once again, thanks for attending, guys. Hopefully, we'll see you guys in upcoming weeks also. And yeah, goodbye, I guess, for now. Bye bye, guys. Thanks for attending. I'll be closing this recording and you can leave the session. Bye bye.